I think it's the same one we talked about. This elaborates on it a bit, I believe. This one is is a simulated. It's a relatively low resolution gas chromatograph, but it represents TBP. It gives you the same estimation of a TBP distillation, but it's not a distillation type, it's a chromatograph. So as you see, there are all these different distillations that are used. Now, the crude oil properties, the API and what's called the Watson characterization factor are probably the two most common correlations or characterizations that you hear. The API, it simply converts the degree API, if you take this formula, 141.5 over specific gravity minus 131.5, it gives an API, and a crude with a high API is light crude, and a crude with a low API is heavy crude. The Watson characterization factor, it gives you an idea. If you recall, we talked about paraffinic and naphthenic and aromatic crude. Well, it gives you an idea if the crude is paraffinic or aromatic. Most people actually say the crude is paraffinic if it has this type of Watson characterization factor, and if it's, or they refer to the crude either as paraffinic or naphthenic. And here, so in fact, the crude could be paraffinic, aromatic, or naphthenic, you know. And the Watson K, it's one of those calculations which we'll see in a minute. Is the cube root of the cubic average boiling point over specific gravity. It's a correlation. So one could sit down and calculate it. It was published in some magazine maybe 50 years ago by a person who was called Watson, and his partner called Hogan. It's called also Watson and Hogan K. It was called, to most people, I think, is known as the UOPK because they work for the same company I work for, UOP. But the competitors of UOP doesn't like to call it UOPK, they call it Watson K. This graph just shows you the API and the relative density relationship. This is an interesting chart. This one shows you the paraffins. This one talks about the Watson K here versus boiling point, and these points are calculated for different boiling points and correlate against the Watson K. And as you see, the paraffins have the highest Watson K. So if a crude has a Watson K of about, say, 12 or 13, you know it's paraffinic. If it has an intermediate Watson K, then you know it's naphthenic. If it has a relatively low Watson K, then you know it's aromatic crude. And the reason people are interested in that, because that affects how you run and design a crude unit. Let's see. Properties of a fraction is inferred from measured trend, relative density, specific gravity, API, or sulfur content, or carbon residue. Or properties from correlation.